wanted to spend some time talking about the path of least resistance and how we can make that lead to behaviors we want in our users. So we hear a lot about, Kubernetes upgrades kind of have a reputation for being difficult, sometimes disruptive. Sometimes that reputation is deserved. Sometimes it's actually not. We've made some improvements, but I wanted to look at ways we can do even better. So this is maybe what we sort of think our users are like. They're going to work really hard to get to wherever they need to be. The current version, the current feature, action required changes, no big deal. They're going to swim upstream super hard. In reality, this is more like what our users are doing. They're kind of floating downstream with the current and trying to steer around the biggest rocks. Wearing helmets, probably recommended. This is just reality, right? You go where the current takes you. And so how can we make the default behaviors, the easiest paths, take our users where we want them to be, where they need to be? So I did want to look at some ways we've made progress. All right, so if we go back a few years, in 2019, we finally got all of the APIs that you have to run a cluster, we got them to GA, right? And so this meant that you have long-term stability guarantees around those APIs. You can use those APIs, write your application, your integration, and it will work forever. We promise not to remove those APIs. We have tests and things that make sure that we don't introduce new hard dependencies on beta stuff, right? So that was good. That's progress. And in 2020, we switched from a 9-month support period to an annual support period. So we still just had 3 releases, but those 3 releases came out every 4 months instead of every 3, so you get a year of support from that. We also expanded support for the oldest minor release for a couple months after we release a new minor version. Why did we do that? Because it turns out if you drop support for the oldest release, the instant, the day you cut a new minor release, you actually need a time machine to upgrade. You have to start qualifying and start your rollout before the new minor release was cut. So as part of the annual upgrade KEP, we also extended support for a couple months beyond the new minor version cut. So no more time machine required. 2021, production readiness review became a thing. So starting in 1.19, you had to provide answers to production readiness questions, and then starting in 1.21, you actually had to have approval to get an enhancement in. So what kinds of questions was production readiness asking? It was asking, does enabling this feature change default behavior? How can you enable or disable this feature in a live cluster? How does SKU work? And these questions are really important because Kubernetes is a distributed system. And so we don't get instant upgrades. You upgrade one component at a time, or one machine at a time. You don't get instant enablement. A feature enables, and then that propagates to a controller, which propagates to observers. And so these questions are super important. And before we were asking those questions, this was sort of what we had. What do you get in a release? I don't know. Good stuff, I'm sure. Really tasty, good features. What do they do? Don't know. Do they work? Don't know. We tested them, but for users, it was hard to understand what they were getting. And so with production readiness review, you actually can look. Here are the features, and then go and read the answers that were given. What does this change default behavior? How can I monitor it? How can I enable it? How can I disable it? I will say, some of those actually still look identical to me. This is actually from the maker's website, whatever. So it's no longer a mystery. And so when you're working on enhancements or you're reviewing enhancement proposals other people are working on, the production readiness questions aren't just paperwork. This is actually super important for us to make sure we're building things users can roll out safely, and for users to be able to read what we wrote and understand what they're getting. And really, the happiest story in 4 words is well, what did I write? 5 words. Does not change default behavior. That's the best. Sometimes that's not possible, but ideally, new stuff comes in and it doesn't disrupt existing users who are perfectly happy. All right, 2022. New beta APIs default off. So remember, we got all the required APIs to GA back in like 2019, but we still had a problem where we'd come up with beta things and we'd release them, and users would start using them in like load-bearing production ways. And even though we had warnings and deprecation notices, and like this is not stable, like we might have to change it before we get to stable, and when we do, we're going to drop the beta. No matter what we do, if it's on by default, people will use it, and they'll use it in like business critical ways. And so we realized we have to change this. Like we still want people to try these things, but trying it should be a very conscious decision. You should have to realize that you are enabling a thing that's not yet stable. And so new beta APIs default off. Actually, this policy went in 2022, but 127 was just released as the first one where we had a new beta API that previously would have been on by default and no longer is. So we still want users to opt in and give feedback, but what we don't want to see is like broad ecosystem use that just assumes these things are on everywhere and are suitable for building integrations that aren't really actively maintained long term. All right, and then this year, this is one I'm super happy about. It's pretty recent. So Kubernetes is built on Go. We, as of the annual support policy, we support a minor version for 14 months now. But the Go version that it was on before this year would actually go out of support like after 8 or 9 months. Go versions are supported for a year. By the time we release, it's like 3 or 4 months old. And so you just sort of fade out into unsupported land, and maybe you'd be lucky. Maybe there'd be a Go CVE, like who knows? And so even though Kubernetes code was supported for 14 months, it was built on a Go version which was out of support. And so that actually in practice made it so that users couldn't rely on that full support period. So we actually worked really closely with the Go team, kind of raised some of the issues that were making it hard for us to update release branches to new Go versions. And I'm super happy that that's been resolved. So as of this year, all Kubernetes minor versions that are still supported are on current versions of Go. And we have a way to qualify new Go versions and update release branches. So this makes our 14-month support period actually usable for the full duration. So I'm super happy about that. All right, so we have made progress. Let's look at some recent things, recent rollouts, feature rollouts, where we hit some bumps and maybe some lessons that we can learn. All right, so I'll pick on auth stuff because I work with the auth-sig a lot, and I know that a lot, so I'm happy to pick on myself. All right, time and pod-bound service account tokens. This was something that turned on in 121. Before this, the tokens you'd give pods would last forever. In 121, they started being time limited and bound to that instance of the pod. So we did a lot of things well here. It was transparent to applications that just would pull a token off the disk and use it against the API. We updated client libraries really far in advance. I think in 114, we updated client libraries to handle reloading tokens. And then by default, we made the lifetime of those tokens last for the full lifetime of the Kubernetes support period. You could shorten that as an admin if you wanted, but by default, pods could run the whole year and still continue working. You'd get warnings and metrics if they weren't refreshing the token. And so it was be safe by default, give admins ways to tighten down if they want, and give them ways to monitor to know if it's safe to tighten down. So what was a bump that we hit with this? Turns out not all applications treat tokens opaquely. And so some were reading this file off disk and then like parsing it out as a JOT and like extracting claims from it and doing stuff with it. There weren't many. We found a couple that were doing this. And so a lesson around this is be really explicit about your API service. Be really explicit about the promises you're making. We hadn't really even considered that that would be an API someone would use. And fortunately, like I said, there were only a couple that we ran into. But it's worth applying to future enhancements. Like, what surface area are you exposing, and how are you portraying that to your users? Are you like leaving it silent? If you leave it silent, they'll depend on it and treat it like an API. If you say this is opaque, you have to treat it opaquely, document that really clearly everywhere you can. Another example, so once we started mounting time-bound tokens in, we didn't need these auto-generated secrets around, and they're actually pretty insecure, and they take up a lot of space, and if you're using like encryption stuff, it's expensive, so we wanted to clean this up. So first step was to not generate them automatically anymore, and then track the ones that are used, and then eventually long-term, we have a plan to clean up ones that haven't been used in like a year. So again, things that went well, we didn't change any behavior on upgrade for existing objects. You upgrade, stuff that you already had keeps working. That's like super important. That's the most important thing. Detection and warning and metrics, like being able to monitor this as an admin to see what's the current state of my system. And then long-term, our plan is to only remove things that we have evidence are unused. So what was the bump that we hit? Turns out applications were scraping the auto-generated tokens and waiting for those to show up. And so we did a big sweep. I think we filed 60 or 70 GitHub issues across like all public repos we could find, and actually went and filed pull requests to help those projects switch to one of the alternatives. Lesson learned, again, be explicit about surface area. This one actually was explicit. But again, be explicit in as many places as you can. Documentation, API documentation, examples. The sweeping for GitHub issues. This was something that I thought we did well here, where we don't always do a good job like evangelizing, reaching out, looking for use. We kind of put things in the release notes and assume that people will see them. That's not a great assumption. So sweeping for public use and like going the extra mile to go out to their repos and file issues or fixes, I think is a good example. And then finally, this was kind of recent. There was a postmortem, I think Reddit did a postmortem about an outage around a kubeatom change, around changing the master label on taint to control plane. And so some things that went well with this rollout, all the workloads that were managed by kubeadmin were transitioned great. Like it was done over several releases, and they add the new thing and then tolerate both for a release or two and then remove the old thing. Like that rollout went really well. Advanced notice, very well. Like within policy, 3 releases of advanced notice. Where we ran into bumps was visibility and control over user-owned things. And so whenever we're doing something that is like intersecting things we own and things users own, we have to be super careful. We can fix all our stuff and we can release note all day long, but it's really hard for us to see if user workloads are ready to accommodate the new change, and we don't own them, so we can't go fix them. And then the last thing that came up in that was removing labels from existing nodes on upgrade. We didn't actually need to do. It was kind of a cleanliness thing, tidiness thing. And that removal was one of the key things that caused Reddit problems in particular. And so, like I appreciate tidiness and orderliness as much as anyone, but it's worth asking, like, do we need to do this step? Like, what are the steps we need to do for this feature? And then what steps could cause problems that we could actually like leave alone on upgrade? All right, so mindset shift. Turns out a lot of people are actually really happy with the problems Kubernetes solves for them. So even though we're still working to fill out gaps and build new capabilities, how can we require less effort from the people who are happy with existing stuff? So Kubernetes is a foundational technology, so let's be a good foundation, not a bad foundation. And this does require more work, right? We're sort of building tunnels underneath skyscrapers as we build out new features and capabilities. This is harder, it requires more work, but it's super important. This use case should always be on our mind. Like as a user, stuff that used to work still works. This doesn't get well represented. Like nobody opens an issue proactively. It's like, hey, I'm using stuff and I want it to keep working. Like they open issues after we release something that breaks them. And so it's our job to keep this use case in our mind as we're designing stuff. Maybe you've seen this. It's always, we can take this too far. Like we can still fix bugs, But we want to be very explicit about the surface area we're exposing. Like, be really clear about the promises we're making with our APIs, with our behavior, with our integrations, and then keep those promises. Again, we like to think this is how users treat Kubernetes release notes, right? Like, they print it out and find a quiet bench in the park and just pour over them. In reality, like, they have so much stuff going on. Often, they don't even read the release notes, or if they do, they just might read the first couple bullets at the top, the action required, urgent upgrade, action required. Aim for 0 action required releases. Like, that should be our goal. If action is absolutely required, make it really clear, not just in the release notes, but with a metric or a tool or something that can be put into an automated upgrade flow so that an admin can script it, right? And say, I ran this check, my metrics are clear, I'm good to upgrade. Like, don't make them go manually hunt through stuff or ask their users stuff. And if you can't figure out how to do that, you're the expert. How in the world are the admin of these clusters going to figure it out, right? And so if you can't answer that question, there's no way they're going to be able to answer that question. So think about that as you're designing enhancements, as you're reviewing enhancements. And then the last thing I would say about this is if action is required and it's not taken, fail fast is better than fail slowly and weirdly in unobservable ways. So if you actually do need a new piece of information, make it a required flag. Like, that's a really obvious thing. I can't start the new version without giving you this information. Don't, like, limp along in some weird degraded way that's difficult to diagnose. And so the ideal is no action required. If you have to take action, give them tools or metrics or scripts to see if they need to give you that. And then, like, don't let them proceed in degraded ways without giving you that. The worst case is someone upgrades and then a month later they notice, like, oh wait, this thing like stopped working in the background and it's like logging every 10 minutes. Like, that's not helpful to them. All right, a couple concrete proposals around this idea of making it safer, less disruptive to do upgrades. First of all, feature flags. Everybody loves feature flags, maybe. The way we've treated feature flags in the past, transitions matter, and to transition safely, you sometimes need to do multiple transitions, right? You add a field to an API, and then you wait a release. And then you put logic into a controller, but it's gated off, and you wait a release. And then you enable it by default, and you wait a release. And because we're now 3 releases a year, each of those wait a release steps is months long. And so finish feature flags is trying to improve the way we do that wait a release step. Instead of just making it time-bound and release-bound, make feature enablement more cluster aware so that a cluster that's on the latest version, all new nodes, all new control plane, can enable features that that cluster supports. A cluster that has older nodes can wait until its nodes are new enough to start letting a new feature be used, instead of just tying it to release boundaries. So if you have interest in being able to move faster instead of waiting a release, comment on the finished feature flags KEP. We still do have like maturity delays, right? We do need feedback. So like the alpha beta GA thing will probably still be there, but there are times when we have to wait a release for no other reason than to safely make a transition. And so this is looking to let us accelerate that. Second proposal is supporting nodes 3 versions older than the control plane. So you remember the annual support extended that last oldest minor release for a couple extra months. It turns out we had an off by 1 error in our math. And so our SKU policy says your nodes can be 2 versions older than your control plane, which is great, unless you're using that 2-month extended period to do your upgrade from the oldest version to the newest version. And so this is fixing our off by 1 error, basically. What this would let you do in environments where it's expensive or slow or disruptive to upgrade nodes, you could keep node pools on older versions, older minor versions, picking up patch releases, which have your Go security fixes now, and then you could keep them on those versions. And if you don't need new features in your nodes, you can keep them on those versions for the full year. And then 3 versions in the future, upgrade your control planes, and then, and only then, jump your node pools onto the latest version. And so we like to think that everybody is just waiting for the latest release for the new features. Some people are, some people aren't. Let's make it easier and cheaper and less disruptive for the people who are perfectly happy with our current feature set to get these node pools onto the newest versions with as little disruption as possible. All right, so to wrap up, this is what I want to leave you with. Where will the path of least resistance take our users? Think about that when you're working on features. Make it so the happy path also takes them to where you want them to be, not sitting on the oldest possible version, using deprecated APIs, unwilling to change because they're afraid of an action required release note that they can't understand how to resolve. Try to have releases with no action required. That should be our starting point. Every time we have something, oh, we'll just make users do this thing. Like, is there a way we could do this seamlessly for them, detect it ourselves, handle it ourselves? If you can't, then make sure you're instrumenting, detecting, warning in obvious ways. And then finally, I would love it if people who are involved in feature rollout or cluster lifecycle stuff can give feedback on these two KEPs. So let's make life better for our users, even if it's a little bit harder for us. That's it. Thank you.
Do you want to take questions, Jordan? We got time for questions.
Yeah.
So I was really surprised, Jordan, that the word downgrade is not in your talk.
All right, so logically,
Sure.
when you have a skewed cluster, you're actually already required to support one minor version back. And so testing at skew, I think, covers the behavior of adding a new control plane and then rolling a control plane back one version. That's where we've actually sat for a while, and it has worked all right. Would I like to see explicit downgrade tests? Yes. I think testing at skew is kind of a happy medium, which we already need to do to upgrade seamlessly, and probably covers like what we need to do a one version downgrade.
Yeah, so if I remember correctly, PRR asks you, like, can you downgrade after you turn this on? Like something like that.
It talks about feature disablement.
Yeah, I guess.
I think feature disablement is more of an issue than downgrade. Because even if you're on the same version, you enable a feature, you get some like wacky data persisted, and then you turn off the feature. Like now your cluster's in sort of no man's land. And actually Daniel's KEP about feature flag stuff is talking specifically about that. Like enablement is not a binary thing, it's a process. Like you are enabling and then the enablement gets picked up by all the components, and then you are disabling and there might be cleanup work to do associated with that. So I think that is a much more important question, and the feature flag KEP talks about that.
So I haven't read that KEP, but I was there when Daniel presented it, or the first time he talked about it. Are we really going to try to wire up everything to be dynamic?
I don't know.
That just sounds so terrifying.
You're the one who wants REST APIs for authorization configuration.
Yeah, that doesn't terrify me at all. I've seen people do so much worse.
Yeah, I think there's a spectrum. Like the first step is like coordination. It doesn't necessarily have to be dynamic. Like you might still have to drive it like statically or at cluster creation time, but having it be observable and like coordinated would be a good first step.
Hi, Jordan. What do you think we need to do across the board in order to support skip version upgrades?
I love that question. So this is my master plan. N-3 node skew this year, skip version upgrades next year. I really would like to see that happen. What do we need to do? we need to stop making the release boundary our transition mechanism. So the feature flag KEP is a good step in that direction. There are a lot of things we do at the control plane level, like what we store in etcd and how we relax and tighten validation, things like that, and feature enablement that are tied to N-1 support because we don't have any other coordination mechanism today. And so if you could tie those to a feature flag enablement and have that feature flag enablement be cluster aware and say, oh, the oldest API server is at this version and the newest API server is at this version, therefore, I still have to store this version in etcd, or I can't relax validation yet. There's actually a pretty small list of things that we tend to tie to N-1 rollout, but making those be able to be triggered off of things that are cluster aware instead of just hard-coded to version boundaries. That's the biggest thing.